All right, so you want to do a quick review on electricity, and then we're going to jump into some multiple choice and then all some paper tools, right? All right, so let's take a look at the summary. Babylon. All right, let's run through a quick review again, because we kind of finished up last week on the gates, right? And today we want to just take a look at a lot of past papers on this, right? We'll start with some multiple choice and then we'll back to some paper tools. Right. First thing, we need to remember that with electricity, we need to know about charges. We have two charges, positive and negative. Negative charge, the electric field goes towards. Positive charge, the electric fields go away. All right. Unlike charges attract, like charges repel. Right. Also, we need to remember that charge is equal to current multiplied by time, and the SI unit is what? What's the SI unit? Coulombs, capital C. All right. Static electricity, we can obtain static electricity by two main ways: friction, that's like when you're rubbing the cloth and the perspex, and conduction. It's like when you're bringing a charged particle. Sorry, that's not conduction. What would that supposed to be? Right, it's not friction, it's something else. Sorry, it's not conduction, it's the next word. Induction, right? It's induction. So it's charging by induction. All right. Those are the two ways to obtain a static charge. Right. Then we talked about current. We said current is charge. Wait, why all these doors slamming? Current is just pulling that man up, please. Current is equal to charge per unit time, which is Q on T. Current and the SI unit is amperes, right? Here's a circuit, and here's all these circuit symbols you need to learn. All right. We have alternating supplies, and we have a direct supply, right? Make sure you can graph them. We have series circuits and parallel circuits, right? Right, you have series circuit, parallel circuit, right? How you know series circuits? Current only has one loop in which to flow, Or there's no parallel circuits, right? More than one, well, more than one, right? Current has more than one path in which to flow. This circuit here is for what? This circuit allows you to get the IV characteristics of any component. All you have to do is put the component in the circuit, right? So like this one here is for filament lamp. Okay. Remember, voltmeter connected in parallel, ammeter connected in series. And you must have your rheostat. Okay. You must have your rheostat. Right? These are two graphs you have to learn. Current for the filament lamp, metallic conductor. Right? We should know Ohm's law, V is equal to IR, and all these formulae here to find work, energy, electrical energy, and power. Okay? Right? Most important table when you're handling questions, how current, voltage, and resistance behave in series and parallel. Right? So you make sure you learn that table. Remember, when you're working up parallel, when you reach right here, 3 on 2, what you have to do? Flip it over, right? Okay. When you're paying bills, remember 1 unit of electrical energy is 1 kilowatts per hour. Oh, not per hour, an hour, right? So you have to make sure your power is in kilowatts and your time is in hours at all times. Okay. In electronics, we have to know what a diode. A diode is a semiconductor device. It conducts current in one direction only. Here's an example of it being forward bias. Here's an example of it being reverse bias. Right? Remember what you're looking for? Current direction in the same direction as the arrowhead. Forward bias. Current direction opposite to the arrowhead. Reverse bias. Okay? Half-wave rectification, right? That's your half-wave rectified circuit. So this alternating circuit is positive, negative, positive, negative, positive, negative. If you're half-wave rectified, you're going to cut off part of it. Okay? And you have something half-wave rectified. You still have more to do. You still have to full-wave rectify and then smooth, right? And then you have all your logic gates. You're not, and you know, and so on, right? You have to learn your logic gates and a symbol. All right. So let's start one time. All right. As I said, we'll start with some multiple choice. Right. I think we started this paper. I'm not sure if we completed it out. I remember one day we did an entire multiple choice, right? Anyway, plenty of repeats in a multiple choice anyway. So let's take a look at this one. This is June 2021. June 2021, right? Right. So what's the answer here? We'll do it one at a time. Actually, you could do this 3 one time. It's on the group, paper on the group. 42, 44, 45. Work out that from message your answer. I'll go back up to 43 that's now. Huh? June 2021. Huh? Not ready? Right, 42 is what? 42, I and B are related proportionally, right? So that will be D. Next one, which formula is correct? Not looking wrong, correct? See, right? You have finished up 45. Hurry up. All right, now we shall. Right, what's all what? 45 is what? R is equal to R is equal to V over I, right? So that'll be 0.6 over 0.4, which is how much? How much we got there? 1.5 times 1.5 V. All right, next one. I left out 43. What will last one here? Right, do protons move? Do the protons move? No, only the electrons, right? So it becomes positive by gaining protons, no. It becomes negative by gaining electrons. That's sounding good. It becomes positive by gaining electrons, no. And it can't gain protons. So the answer is boy, right? Next one. (46, 47). Huh? Yeah, what you tell me. See, so yeah, but right, 46. What's the force keeping them apart? Any guess? Is it magnetic? Nah. Centripetal? No, it's not moving in a circle. Electrostatic? Most likely. Gravity is at vertically downwards. So the force that probably keeping them apart could be electrostatic. Right? So that would be cut. What about 47? Which of the following here DC? AC is what? There's a constant change in direction, right? Positive, negative, positive, negative. So which one of these here will not do that? Apple? Yeah, Apple is positive only. All of them still good negative, right? 47 is Apple. Very good. Magnets. This one here, 49. 49 is what? Nice job, Samira. Zane, message post my boy. We shall see answer and volunteer. As soon as Zane put D, we shall say yeah, D. As soon as you know the man with a second. Right, yes, the answer is diode. Right? The answer is a diode, right? Next one. 51. Right, series. Which of the following best represents series? Gone. B. Right? Only one loop, right? Come in here. Right? Any more on this paper? Oh yeah, look man, one more. Which of the following? There's the AND gate.
Yeah. Oh, I think my. Yes.
Right, correct. The answer, boy. Right, let's try one more here. Let's try one more multiple choice, right? Papan, come on. Let's start here, 36. Work it out fast and more again.
Okay, all right. You know that?
All right. Right. What you all got here? So when A and B is 0, here is 0, here is 0. So here is 0. Here will be 0, 0, and here will be 0 as well. That's okay? Yeah? So the answer is 0, 0, right? Right, you have 1 here. Root means square. Oh, right. This is something that's not really on your syllabus, huh? There's more keep thing. Anyway, what is here? So sometimes here's what has happened, right? I'll give you the answer to it, but I don't think it's on your syllabus as far as I remember. I'll just check to make sure. What year is this? 20. No, they're different here. All right. Well, let me just explain what they're saying here, right? What you have here, Celine, is an alternating value. But an alternating value always changing, right? That's okay. So what they do is there's something called an RMS or average, right? There's an average value for this alternating supply. And that average value is kind of like a DC equivalent. So for example, if I wanted to convert this into a DC value, there's something called an RMS value. Root mean square. It's like an average. Okay? So like this continuous change has an average, right? And that's called the RMS value. So the value of I at the time T1 is called the peak value. You'll see that? But I just want to explain what they mean by RMS. RMS means average. Okay? But all they wanted is when is T1? When is T1? What is that value I1? Right? So really and truly, I don't know why they put this. That is something that you should know. But you'll understand what RMS means? RMS means the average value. Right? So it's like you take the alternating and it converts it to average. That average is the RMS. Right? But the answer for this question is simply when the time is T1, current is I1, which is your peak value. Right? Next one. What's the answer here? Yeah, look at the graphs, right? Right, you'll come message online, huh? Whatever you think is the answer. That'll be either something, that'll be one of the answers there. It had to be A, B, C, or D.
I like that. Have to be.
Recall your name, right? All right, let's see what we have. Let's see what we came up with. Which of the following combination correctly identified current? These currents, right? Current with a greater frequency. Please remember, frequency is equal to 1 on period. All right. So which of these has a greater frequency? The period here is 0.01. So the frequency is 1 over 0.01. That's 100. Here the period is equal to 0.02. Right? The period is equal to 0.02. So the frequency is 1 over that, right? How much is that? 50? Yeah. So which one has the greater frequency? Keshav? 1 or 2? 1 has the greater frequency, so it has to be A or D. And which of them has the greater peak value? Keshav? None. So the answer is dog. The answer is dog. All right? Because they both have the same peak value, 2.5. Yeah, Halls? Oh, you want one? Okay. Next one is to you. 40. So a glass rod is rubbed with a piece of silk and it becomes positively charged.
Hello, Joe.
You see which one, huh?
I
Vishal, I can't believe now.
Sir, yes, outside aerobic. Aerobic.
I was disappointed there, Vishal, man.
Not me, pa.
Right, 40 is what? So a glass rod is rubbed with a piece of silk and it becomes positively charged, right?
Yes.
It becomes positively charged. So the glass rod what? No, the glass rod became positive. So it lost electrons, right? Boy. Okay. Next one. 41. Yeah. What you all think? 41 is Apple, right? Electric fields always go from the positive to negative. So Apple. Next one, 42. Nice one. 42. Vishal. Hey, let's stay quiet and hurry up now. Hurry it up, man. Right, yeah, 42. Aria, what do you think? The voltmeter has a very high resistance, so it can be placed in. Is it placed in series? Voltmeter? Parallel, right? So which one, A or C? What's that? The ammeter is in series, the voltmeter is in parallel. So which one then makes sense, A or C? Why does it have a very high resistance? So it doesn't affect the circuit, yes. Right? You don't want to pull any current out of the circuit. So the answer is Apple. Nice, good job online. Which of the following statements about insulators is true? Yeah? What y'all think? Nisha? Boy? You sure? So all electrons are bound firmly to the atom in the insulator. That sounds good. An insulator, in an insulator, many electrons can move freely. No. An insulator could be charged by Robin here. 1 and 3. Boy. $44. Read 44. Huh? What do you think? C? All right, we will see. We will see that now. So item 44. Item 44 refers to the following diagram, which shows a small negatively charged, right? So this is negative, right? Between the two plates, here's positive, here's the negative terminal. So here will be negative, here will be positive. All right. So which of the following indicate the direction in which the dust particle will move when closed? When closed, negative will be attracted to the positive, so it will move downwards. Cut. C. All right. Next one, 45. Oh, yeah, that's generator, I'm saying. 46. Hold on, I'm quick next week, I'll say. Yeah, physics might get it. Add mass one there. 46. Which one correct there? Right, the question said parallel, right? So you know this wrong and that wrong. Is it D? D? Right, D is totally wrong, right? That will only work for two resistors, right? One says boy. So dog will only work for two resistors. So it'll be this product over this sum. Boy, nice. 46. It's taking forever, right? 47, I mean. Nice question here. What y'all think there? Using the information given, what do you think will be the current pairing? Right? Please remember that the higher one will, higher the resistance, the what? Smaller the current, right? So the one with the higher resistance should have a smaller current. What y'all think here? What's that? Boy? Dog? All right. Guess now we will see. Right? The answer correct is dog. Right? So the higher resistance goes on top, which is 4, and the lower resistance underneath, which is 2. Sorry, what did I say? Lower resistance means the higher current coming here. The lower resistance means the smaller current coming here. 4 plus 2 is still 6, and the potential is the same. Last one before you go to paper tools, 49. Which one here looking correct? Oh, it's magnets. Sorry. Well, you should know this. Right. I'm gonna be fair and not give all of that. Then. Right, we did 58, 51. This one here, 52. Last one. 52. See, but you didn't read the thing and you send the answer already. What is their answer, man? Right, correct, the answer is C. Right, because it's in series and C is the only one that fully in series. All right, nice. Let's go to our paper 2 now. Right, we did a lot of let's take a look at June 2018. Right, yes, remember your little electric fields here. Try that fast. What is an electric field? Huh? Yeah, paper 2, yeah. Or June 2018. All right. Define the term electric field. Region around, right? Good. Electric force. So the region around an electric charge when electric force is experienced, right? You have to say force. Huh? Oh, due to this charge. All right, all right. Like it pass. Right, but it's a region around an electric charge, right? Nice. Electric field lines go from where to where? They go from positive to negative. So if it's a plate, remember it's straight lines and they're evenly spaced out. All right. Try to make sure they're evenly spaced out, right? What is one hazard of a static electricity? Huh? Right here, like during fueling of a car, you want to make sure the car has no static charge. Right, and what's one useful example? Photocopying, painting a car, right? Plenty of examples. Next. Right, try this here. I can't really zoom in much more, right? Please pay attention to this. What is the unit on the x-axis? Huh? Time, right? What's the unit? Milliseconds, right? Milliseconds. So this is 10 to the minus 3. Right? Try that fast. Try that quick.
Online. Yeah, we were shooting more.
You shall talk to me and I hope you. There you go. That's all right, yeah, go hide it, hide it. Why do you tell your father? Why do you tell that? I look at things, I think, that makes sense. Too wide, too wide. You don't know what I'm saying. Yeah, you're gonna be for sure. He's us.
Yeah, this one. All right, so anybody have labs for me? No? Right, what is the peak to peak voltage? So you look at the highest voltage to the lowest voltage. Peak to peak, the value of the peak to peak is 10 volts to minus 10 volts, right? Or you could write it like this. 10 minus 10. That value is 20 volts. So the peak to peak is 20, right? You could also write it like that. What's the period? The period is 8 milliseconds or 8 by 10 to the minus 3 seconds. What's the last part? The frequency. The frequency is 1 over period, which is 1 over 8 by 10 to the minus 3, which is how much? Sorry? 125? 125 hertz, right? Remember to pay attention to all the SI units, right? Right? Always write in the SI units. Let's go again. Right, this is 2015. Yeah, everything is 2. Jan 2015, right? Start here. One mark each, right? Right, should be done. Chevelle, what's the formula for part 1? Right, V is equal to IR. Whenever they ask things like this, I know it's just 1 mark, but just tell them what V is, what I is, and what R is, right? Resistance and parallel formulas. Right, and you also have the product over some method, right? Formula. Okay, nice. You might have to hopefully you can see it. Right, we don't have much time. I wanted to try to work out this whole thing, right? We shall exclude, please. We're playing with it. Huh? Silk? Was that a silk? Last rod? Alright, can you do part B, please? Last question. Next week is magnetism, right? Okay, I might give you a break next week after, right? The people in the group. Or you can take a little pick and see. Sorry. Take your time, write it down. Put in your little values. Let's see what you get, right? I will draw the circuit a little bit, right? So the circuit, put in the values that you have. Right? You will start 0 to 100. And to give you the rating at the bottom. Okay. Try it out. 5 minutes. Finish. What's the resistance of the bulb? That's easy, right? So the resistance is what? V over I. Right? Remember, any answer, formula, substitution, answer. So I write the formula. I'm going to substitute the values now. Answers 10. Go ahead, finish it up quick. Huh? You think we didn't go with the boss? I know you see. We don't have that. Piece of the road, right? The road. So we had to stop. Hurry up, last two parts. Gotta walk. Right here, remove the one time. Hurry up. Last two parts. Alright, so we shall have, so assuming that the resistance of the bar remain constant once lit, calculate the ammeter reading if the rheostat at 100. So here's at 100 ohms. Here is 10 ohms. Right? And they want us to find the right, they want us to find the ammeter reading. Sorry. Yeah. Sorry, I thought that was the bulb. Here is 10 ohms. Yeah. How they connected? Connected in parallel, right? So first to work out current. Current is voltage over resistance, right? We know the voltage, but we do not know the resistance, right? Because we have two in parallel here. So we had to work it out, right? So you're working out the resistance in parallel. 1 on R is equal to 1 on 10 plus 1 on 100. So 1 on R is equal to 100 here. You'll get 10 plus 1. 1 on R is equal to 11 over 100. R is 100 over 11. Anybody got that? And then you work out the current. Current is equal to your voltage over 111. I am getting 0.33. Just check the calculator now, please. Anybody got 0.33? Check it and see. Yeah? 0.33. Is there a danger in reducing the rheostat too much? What will happen? So here what to do, right? Think about this. If we make this value larger, what will I do? If we make the 100 value larger, what will I do? Oh no, we had to say how, maybe or maybe not. We had to say how. So let's just make up a value, right? Let's just make up a value and let's do my favor and work it out. Let's say this value went up 1,000, right? What you will get here? You'll get 1,000 underneath here. You'll get 100 plus 1, right? So you will get 101 over 1,000 or 1,000 over 101. And then see what will happen. See what will happen with the current value. It'll be 3 over 1,000 over 101. .3. Check it from now, please. Much you got 0.303. So by making the rheostat value large, hold on, the first question we got. The first question we got was 0.33 was the answer, part 2. Everybody got that? I just find that strange because look at the rating of the bulb. What will happen if the current there's something wrong with this. What will happen if the current is more than 0.3? Now blow the bulb. Huh? It will be off. Yeah, something off right here. I gotta check back this working. What will normally happen is that if the resistance value here too large, a larger current will flow. So that should blow the bulb, right? But the rating is 3. All right, I'll check back part 2, right? But in part 4, they said that the assumption made in 2 is wrong, right? Not in 1, the 1 and 2. The assumption made in 2 is wrong. Right, so the assumption made in 2, where they say the resistance remain constant, is incorrect. Reason for that is, what does the IV graph look like? What does the IV graph look like for a filament lamp? Is it a straight line? It's a straight line with a little curve. Right, so it means as the current goes up, it gets hotter and the all right, hold on, I'm gonna switch it. Yeah, what has happened is that as you increase the current flowing through, the resistance is changed, right? The resistance is higher, right? Because the bubbles get warmer and the resistance increases and current flowing is less. All right, that's what's happening in part 4. Right, because so the bulb resistance, yeah, come on. The bulb resistance varies with current, right? The more current, so write this down. The larger the current, the greater is the resistance of the bulb. Oh wait, I say the wrong thing here in part 3. I know it's my mistake. What did I do in part 3? In part 3, I increased. Yeah, so right, that's why it wasn't working out. Yeah, so I made a mistake in the calculation. All right, so let me just go back and fix that there. Sorry about that earlier. I made a mistake and increase. I don't know why I saw the word increase. It's really reduce. So drop this value to much smaller and then you work it out. And it will recognize that when you work out current, the value is much larger. I made a mistake and increase. That's why it wasn't working out. But again, I still do agree with part 2 because the part 2 value is 0.33 amperes and the rating is 0.3. All right. So we have a slight problem there. Okay. All right. That's it. So remember that when the current goes up, you need this one first. So on. All right, so that's the end of the lecture for me. Next year we start magnets, right?